So up to this point, we're talking about the different types of loading. We started with remember the axial loading, then we talk about the torsion, then we talk about the bending, and then we talk about the shear. Remember that? So these are the 4 types of loading that we can have on any member that are given, no matter what that member. Sometimes we have only one of them, sometimes we have combination of them. The 2 things that I want to mention that no matter what type of loading we have, we only have 2 types of stress. It's going to be either normal stress or shear stress, correct? When we talk about the axial loading or bending, remember that if there's an axial loading, it causes the normal stress. If you have a bending, also it causes the normal stress. If you have a torsion or shear or lateral force, those cause the shearing stress. So, as I said, sometimes we might have one of them, sometimes we have combination of them. If you have combination of them, we calculate the stress from each of them, and then we add them together to get the stress on the element. Now, in these chapters that, okay, we assume we done this analysis, and we get those stresses, correct? So we know those stresses. And these stresses, we calculate them for what? When they are either parallel to the x, y, or z axis. Anything we calculated up to this point was that is either along the x, either along the y, or either along the z axis. Now in this chapter, we want to see that what if we want to analyze a member that's not along x, y, or z. Or let me ask you in other way. How I'm gonna make sure, how I'm gonna know that when I calculating the normal stress and the shear stress, how am I gonna show that the maximum happen along the x, y, or z? When I bend that, for example, member, and I calculate the normal stress from the bending, and it gives me the bending along the length of the beam. How am I going to show that that stress is the maximum along the length of the beam? Maybe it's, if I cut it 30 degrees, it's going to be the largest at that angle. So basically 2 things we want to know that. First of all, if we are interested in any given angle that is not parallel to x, y, z, how we are going to find the stress on those angles. Second of all, at what angle does the stress become maximum? As I said, it might be maximized along x, y, z, but it might maximize on some plane that's not parallel to any of those axes. So that's what we want to do. So in general case, general case, if I bring a cube out and says, okay, this is an element, and I said, look at the general stress case that I have. So in general case, I'm gonna have a stress along this x along the y, and along the z. So I'm drawing on these 3 surfaces. We have exactly the opposite of that on the other 3 surfaces as well. So I have this sigma along the x, I have this sigma along y, and sigma along, so I have 3 normal stresses. And then I have the shear stresses, 2 on each surfaces. So in total I have 3 normal stress and 6 shear stress on these 3 surfaces, and I have exactly the opposite of them on the other 3 surfaces. That's the general cases that I would have. And in those cases, remember that the here the tau xy is equal to tau yx, tau xz is equal to tau zx, and tau yz is equal to tau zy. So the zx, and the xz, zy and yz, yx, and so every couple they're equal. They're just in different directions. So one of them goes there, one of them, but they're equal. For example, if I look at the yx and xy, going this way, going this way, the direction is different, but the magnitude is exactly the same. So this is the general case of the stresses I have on the element that we have. For the purpose of this, I remember that this very same thing we can talk about the strain. So we are not going to talk about the strain. We don't have time. We just focus on the stress for now. So this is a general case. But just to make it a little bit easier to understand that, we are going to assume a case that we only have a stress on the y and x axis. We don't have a stress anywhere else. So only everything that's going to be on the y-x plane. That's called the plane stress. In the plane stress, basically what we are going to say that we're going to say the sigma z is 0. So sigma z is 0, and the tau cx is equal to tau xz. That's also 0. So that's the plane stress. So we assume anything that related to z axis is just simply 0. We only have stresses on the x-axis, on the xy plane. If I look at it that way, I'm going to draw them. So what I'm going to have on the xy plane, I'm going to have the sigma y and the sigma x. So I have the sigma x going out. I have sigma y going up. And then I have tau yx tau yx, and I have tau xy. So that's all I'm gonna have. I'm not gonna have anything. So everything else I'm gonna assume is 0. And then I have them on the other two surfaces as well. So I'm simplified that to this case, and then I'm gonna look at this case. Got it up to here? So now I'm gonna draw that plane stress in 2D. So if I go ahead and say plane, not plans. Plane. I'm going to draw the plane stress in 2D. If I draw it in 2D, what I'm going to have is, so basically I'm going to look at it from this angle. So I'm getting rid of the z. So I only keep the x and y. So what I'm going to have is I'm going to have the element like that, and then I'm going to have the sigma x, sigma x, sigma y, and sigma y. And then I'm going to have the shear stresses be tau y x. That's going to be tau x y, and then I have the other two on the other two surfaces. So that's going to be my elements if I draw them into 2D shape. And the other two come here. Okay, so that's the 2D shape of my element. Now now the question is that, what if I rotate that element? But if I go ahead and say, maybe, you know what, I'm gonna slightly, so if it looks like this, I'm gonna rotate it like that. Then what's gonna happen there? So if I go ahead and say, hey, look, let's have it, and going from this to this angle. By the way, so that's going to be my x and y axis. So I'm going to slightly rotate that, and then I'm going to have the shear stresses on that as well. So I'm going to call this new one. I'm going to put the prime on the new one. So whatever I have here, I just put the prime on the new one. So assume when I rotate that, it's going to become sigma x prime. And do a sigma y prime. And it's going to be and we have this the same as the shear, so we have the x prime y prime. Tau x prime y prime, and then I have the tau y prime x prime, and I have the other two here. So I'm gonna this is my x and y axis. And I'm going to rotate them toward these two. So it's going to become x prime and y prime axis. In other words, this is the x prime axis, that is the y prime axis. And then the angle between them is going to be that angle, or that angle. That angle is theta. The amount that I spin it called theta. my x and y spin to x prime and y prime. So I know this, so this is the known case. Usually when we are dealing with, talking about that, okay, this is the known case. And this is what we calculated up to so far. Anything we calculated is either along the x or y axis. This is the new one and this is the unknown. So we want to find what's happening here. So basically if I go from that x, y there to here, x, y, x prime, y prime, the angle of theta. So I have the x, y, I want to find out what's happening on the x prime, y prime. To calculate. To do that, what we are going to do is, I'm not going to do the entire analysis, but I'm going to just show you how to do that, okay? So I don't write the entire step, I will just show you how we are going to. Look at that element. If I have that element, and just say, okay, this is my element. There. And I'm going to cut that element like this. I'm going to cut it from here. With that angle is the theta. We're going to cut that here. Okay, I'm going to cut that there. I'm going to bring it out. So that's the theta. So, if I consider that length, delta A, how much would be this? And how much would be this? So, this part would be delta A sine theta, correct? And this one would be delta A cosine theta, this length, or the area. I'm drawing in the 1D, but it's actually the 2D elements. So if this is delta A, this delta A sine, this delta A cosine. So now if I go ahead and put the forces on the element I just draw, and I know that, so this is the force that I'm going to have here. Going to be here, sigma x. So these are the forces times the area, delta A sine theta. The forces here is going to be sigma x delta A cosine theta.
Should it be sigma y?
Yeah, this one is sigma y, yes, you're right. That's the sigma y. The sigma x delta A cosine theta. Yeah, that one is sigma y, thank you. and this one is going to be tau xy delta A cosine theta. And this one is going to be tau xy delta A sine theta. So these are the known forces, correct? Because we know the sigma x, we know the sigma y, we know the tau xy. Okay, so those forces I know them. Now, if I go ahead and say, okay, look at it, I'm gonna put the forces on the new axis there. So I'm gonna have this one, which is gonna be the sigma x prime delta A, and it's gonna be this force, which is gonna be tau x prime y prime delta A. Okay, so I have the element, I cut that part, I bring it out, and I put the forces on that. Now, if I go ahead and write the equilibrium forces, I can find the sigma x prime and tau x prime y prime. So any question after here? So very quickly, I have the original one, I spin it, I take the original one and cut the plane along the angle, the new angle, and then I put the forces on them, and then I write the sigma xy, the equilibrium equations. I have 3 equilibrium equations, so I can find the sigma x prime, the tau xy, and also the sigma. So now if we write those equilibrium equations, they are in the book. If you want to see how they write it, you can find in the book. We are going to get 3 equations. So I guess 3 sets of equations that's gonna give me basically they're called transformations equation. So the first one would be the sigma x prime would be equal to sigma x plus sigma y divided by 2 plus sigma x minus sigma y divided by 2 cosine 2 theta plus tau xy sine 2 theta. The next one is the sigma y prime sigma y divided by 2 plus minus sigma x minus sigma y divided by 2 cosine 2 theta minus tau xy sine 2 theta. And the third one is the tau x prime y prime is equal to minus sigma x minus sigma y divided by 2 sine 2 theta plus tau xy cosine 2 theta. And the last one is that sigma x plus sigma y is equal to sigma x prime plus sigma y prime. So, equation 1, equation 2, equation 3. So these are the basically the first three equations are the important equation that we are using it for the transform. Remember that the sigma x, sigma y, and tau xy and theta are all known. The equation a little big, but we know the sigma x, we know the sigma y, we know the theta. We just need to plug it into these equations. If you plug it in those equations, it gives you the stress in the new angle that we have. Any question? So the next thing is that we want to look at, so this is the first part. If we are given any angle, can find what's the stress on those angles. That's the first part we're looking for. We have the horizontal and vertical, then what would be if we are given any other angle. The next part is that we don't know if the sigma x or sigma y or the tau are actually the maximum here. Where they are going to get maximized? At what angle they would be the maximum? So when we are designing, we know that, okay, it's going to break along that angle. So it's not going to break horizontal. Remember that when for example, on the axial load, I was showing that the tension, when they pull away that element, it was breaking at 45 degrees. So it was that, okay, that's the plane that's going to break it. So how we are going to find out that 45 degrees? How we are going to find out where the stress, either the shear or the normal is going to become maximum. And that's going to be we call it the principal stress. principal stresses and all max. First of all, the principal stress is the plane. The sigma min and sigma max are principal stress. So before I start to work on that, so I will say that sigma min and sigma max, and sigma min, these are principal stresses. So that's the very first. So here, if I go ahead and eliminate theta between equation 1 and 3, so eliminate theta from 1 and 3. If I get 1 and 3 and get rid of the theta between them, what I'm gonna end up with is gonna be sigma x prime minus sigma x plus sigma y divided by 2 plus tau x prime y prime. Both of them to the power of 2 is equal to sigma x minus sigma y divided by 2 to the power of 2 plus tau xy to the power of 2. So if I get rid of that theta, that's what I'm gonna get. Now, if I go ahead and say that I'm gonna say the sigma average is gonna be sigma x plus sigma y divided by 2. And then I'm gonna say the R is gonna be square root of sigma x minus sigma y power of 2 plus tau xy to the power of 2. If I write those equations, if I substitute this in the top equation, what I would get? If I substitute these there, I'm gonna get the sigma x prime minus sigma average to the power of 2 plus tau x prime y prime to the power of 2 is equal to r squared, correct? If I replace these two on that. What is this equation from the math? What shape is that? It's a circle. It's a circle with the, so this is a So that's the circle equation with center. What's going to be the center? Sigma average and 0. Remember the equation of the circle was x minus the center to the power of 2 plus y minus center to the power of 2 is equal to the radius to the power of 2. The equation of the circle. So x minus the center to the power of 2, y minus center to the power of 2 equals radius to the power of 2. So that's the equation of the circle. Now if I go ahead and draw that circle, so if I want to draw that circle, one axis is going to be sigma x prime, one axis is going to be tau x prime y prime. There. So I'm going to go ahead and say, okay, I'm going to draw the circle. So one axis is going to be sigma x prime y, sigma x prime. And one axis is going to be tau x prime y prime. So what's the center of that circle? I'm going to draw a circle first. I can get it right. Okay. So the center of that circle . Center is sigma average, right? The center is the sigma average. It's going to be, the center is at sigma average and 0. Sigma average and 0. So that's going to be where it's going to be the sigma. That's going to be where it's going to be the center. The tau would be 0. The x would be the sigma average. What is this point? Max. That's the maximum sigma I'm gonna have. What about this one? Sigma min. So it's gonna be the minimum sigma I'm gonna have. What about the point at the very top? This tau max. So that's going to be the sigma mean. That's going to be the sigma max. So if I draw that equation, this is what I'm going to get. Now, if I have that point, this case, I'm consider that as M with the, I'm gonna just call them sigma x prime 1, sigma y prime 1, for this very specific case that I have. And x prime y prime 1, y prime x prime 1. If I have, and it says that, okay, on that set I have the sigma x prime 1 and tau x prime y prime 1. This case. So, is a sigma x prime 1 and tau x prime y prime 1. So if I want to show them on that plot, so this is my case, I want to show it on this plot. That point is going to be sitting somewhere there. So that's going to be point M. Sigma x prime 1 and tau x prime y prime 1. Whatever is the value. Whatever is the value. So if I show them on that circle, it's going to stay there. That is going to be the R, correct? That is the R. Now, I'm going to say what it is, but for now, just accept it from me. This angle is 2 theta p, and this angle is 2 theta s. I'll tell you what they are. So the first thing is I want to find where it becomes sigma mean or max. So find theta for sigma mean and max. Correct? So look at when the sigma it becomes mean or max, what happened at the sigma mean and sigma max? The tau would be tau would be 0. The tau x prime y prime, that tau would be 0 at the sigma mean and sigma. When it's sigma mean, I have no shear stress. When the sigma is max, there's no shear stress. Correct? So, if sigma is sigma mean or sigma is sigma max, then tau would be 0. So in the third equation, the third equation for the tau, if in equation 3 I put the, so in equation 3, put tau x prime y prime is 0. If I set the tau x prime y prime 0, then the theta I'm going to calculate from that would be related to the, then theta would be related to sigma min and sigma max. So if I go in that equation, in the equation 3, I set the tau 0, and then find the theta. The theta would be the sigma min and sigma max. And if you do that, then what you are going to get is that you are going to get tangent 2 theta p is going to be 2 tau xy divided by sigma x minus sigma y. That's what you're going to get. So that's the 2 theta p that I show you, I draw them there. So this is the angle from whatever I have right now, go to get to sigma max. It's the angle bring me from where I am right now to the sigma max. From that point to the sigma max. It usually gives me 2 angles, so that equation generally gives me theta p1 and theta p2. So if you solve it, it gives you theta p1 and theta p2, and so these are the angle corresponding to sigma min and sigma max. So these two are angles corresponding to sigma min and sigma max plane. So that's where it becomes sigma min and sigma max. Those planes, they call it, what are they? They are principal planes. So remember that when I get to that plane, whatever angle is that, so when I got that, I'm going to have my elements going to look like this. That's my element. And then I'm going to have the sigma would be sigma min. The angle that I rotated from the xy, so if this is the xy, prime, y prime. That angle is theta p. Other one is going from here to here. So it's one of them is theta P1, one of them is theta P2. So one of them is those theta P, one of them is angle, how much you rotate to get to the x prime, one of them is how much you rotate to get to the y prime. And then here, the 2 points is here. First of all, the tau is 0 in this case. And the second is that theta P1 minus theta P2, they are always 90 degrees apart. What's their magnitude? Look at here, the magnitude of the sigma min and sigma max is the sigma average plus R and the sigma average minus R, right? So sigma average plus R gives me the sigma max, sigma average minus R gives me the sigma min. So the next is the find the magnitude of sigma mean and sigma max. So there we are telling where it happens. Here we want to say, okay, how much is going to be? And it says that it's going to be sigma max is sigma average plus R, and sigma mean is sigma average minus R. So if I put them into the equation, I would say that the sigma max and sigma mean is equal to the sigma average, which is the sigma x plus sigma y divided by 2 plus minus R, which is sigma x minus sigma y divided by 2 to the power of 2 plus tau xy to the power of 2. Now, which of these angle related to which of these two? How we are going to find out? I have sigma p and sigma. Which one is related to which one? How I'm going to find which theta is related to what angle? You can't say it, but just look at it. There is no way that you say, okay, for example, if one of them is 10 degree, one of them is 100 degree, there's no way to say which one is means, which one is what. The only way that you can do that is that you have to go and put the theta in the equation 1 in your sheets and calculate the sigma for that theta. So basically you have to put one of these theta in the equation and find the sigma corresponding to that. And then you will find out which one is which. So you cannot tell it by just looking at it. So to find out which theta p is related to sigma max or sigma mean, you need to put one of the theta p in equation 1. So you put it in the equation 1 and calculate the sigma from there. Calculate sigma from that equation. Related to sigma mean, sigma max. So we need to put one of the theta in the equation 1 and calculate the sigma from that equation. Then we can find out which one is related to which. So if you put the theta there and the sigma you calculated comes out as a sigma mean, so that theta is. So for example, assume I have the 10 and 100 degrees. I put 10 there. If the 10 calculated and the sigma max came out, it means that the 10 is related to sigma. If I put 10 and then the value came out was the sigma mean, the 10 is related to the sigma mean. Let's see if it's sigma max. Let's see if it is sigma mean or sigma max. So that is how we find out that's how we find out where we have the maximum and minimum happening and what's the magnitude of this, the sigma minimum and max. What's left? Where the tau max is happening and how much is the tau max. Okay, so we find out where the sigma mean and sigma max happening and what's the magnitude of that. Now, where the tau max happening and how much is that tau max. So question up to here. Before I move forward. So those are the principal planes, not the tau max. So I want to see where the tau, so find theta for tau max. So basically I want to see where the tau max is happening. So when the tau is max, if you look at your circle, when the tau is max, the sigma would be how much?
Sigma average.
Sigma will become average. If the sigma is average, so if sigma is sigma average, then the tau is tau max. So, same as before, in equation 1, this time. In equation 1, you are gonna put the sigma prime equal to, in equation 1, you set the sigma prime equal to sigma average, and then from there, find the theta. The theta would be related this time to tau max. So theta would be related to tau max. And if I go ahead and calculate that theta, it's going to be 2 theta s, the tangent 2 theta s is equal to negative sigma x minus sigma y divided by 2 tau xy. So that is where the maximum shear stress is gonna happen. Again, it's gonna gives me the 2 theta. It's gonna be theta S1 and theta S2. And there are going to be angle corresponding to, there are angles corresponding to tau max and tau min. Remember that the tau max and tau min, they have the same magnitude. They're just, one of them is positive, one of them is negative on that circle. One of them is positive tau max, one of them negative tau max. So the magnitude wise they are the same. There's one of them positive, one of them negative. Now again, if I want to show it like that to see what happens, if I draw my element, so assume this times this width. And when it happens, it's going to be tau max and then here's the important part, that this is going to be sigma average. So of them would be so when the tau is max, the sigma would be sigma average. Again, like here, the angle between the theta S1 and theta S2 is always theta S1 minus theta S2 would be always 90 degrees. So in this case, if I want to draw them, the angle for them, so it's going to be X and Y as rotating, assume it's rotating this way this time. X prime, Y prime, then that's one of the theta S. The theta S, that's the theta S. And then the other point is that theta S minus theta P minus theta S P minus theta S is always 45 degrees. So, when we have the sigma max and sigma mean, the tau would be 0. Correct? When I have this tau max, the sigma would be the sigma average. And the angle between these two is always 90 degrees, always 45 degrees apart. This is what we, if you remember at the very first chapter, we were talking about the normal and shear stress. It said that if wherever the normal stress happen, the shear stress happen at 45 degrees. Because in the axial load, the maximum is maximum is 0, so the maximum for the shear would be 45. Now that's where it happens. Then it's at the magnitude of the tau max. We want to find magnitude of tau max. So how much the magnitude of tau max on that circle? On the circle, the tau max would be?
R.
Just the radius, yes. So the tau max is R. So therefore, the tau max, the magnitude of the tau max would be the square root of sigma x minus sigma y divided by 2 squared plus tau xy squared. And the final note I want to mention is that all these analyses are correct only if you have a plane stress. With in the plane stress, the sigma x would be 0, the sigma z would be 0. Xc is equal to zx x and z and zy would be 0. Zx and zy. Zx zy would be 0 as well. So this is in the first part we learned that okay, those 1, 2, 3 equations. Okay, the equation 1, 2, 3, it tells us if we rotate it at some angle, what would be the sigma on those angles? And then here it says that now if we want to find out where the sigma become maximum and how much it is, and where the tau become maximum and how much it is. So that's the entire thing we wanted to cover. The equation wise is, the concept wise is very complicated, but the example, when we put the example in the example, it's not that difficult to actually solve the problem. Question before I move to look at 1 or 2 problems, see how much time we got. So if you know the concept of that, usually the problem, if you want to solve the problem is not that difficult to solve. We'll see that. I would say relatively simple to do it. So assume I've given an element that is look like this. So I have an element like that, and the shear force is applying on that. The stress is applying on that is 50 megapascal this way, and 10 megapascal in the y direction, and then 40 for the x1.
Are these all in megapascals?
Yeah, they're all in megapascals. So I want to know that so what it wants to know is that what's the theta p, the principal point, so theta p here wants to know that. And then sigma mean and sigma max. Theta P1 and theta P2 basically. And then it wants to know the maximum shear stress for the normal stress. Then it wants to know the tau max and sigma average. It wants to know all those. Okay. So, first of all, let me see what I have here before I start. What's the sigma x here?
Just be 50,
50, positive or negative?
positive.
Because
It's heading out. It's under tension. Tension is
Tension.
positive.
so it's going to be positive. Sigma y is negative 10, correct? Because it's compressing, so it's going to be negative 10. And the tau xy is 40. So these are the three values that I have. Now the very first thing I want to ask is this sigma theta p. How much? What was the equation for the theta p? 2. So we're gonna find principal planes, or basically theta p1 and theta p2. So 2 tangent theta p was, tangent 2 theta. One other thing before I forget to mention that, remember every equation we have is a 2 theta, 2 theta. Why? On the circle, we go 360, correct? But when I rotate that, I rotate it 180. So everything here under happens. So if I go here from 0 to 90, on the circle I go on from 0 to 180 because everything happened 2 times. That's why everything is 2 times here. And 2 comes from there, just you wonder where that comes from. So it's going to be 2 tau x prime, tau xy divided by sigma x minus sigma y. And then if I go ahead and calculate that, the tangent 2 theta p is going to 2 times 40 divided by 50 minus 10. It gives me 2 angles, so theta p. It gives me 2 angles. One of them is going to be 53.1, and one of them is going to be 26.6 degrees. No, I calculate they are not right. Can't calculate them. But I think one of them is going to be 26.6. Yeah, one of them is going to be 26.6. And the other one should be 116.6. Just make sure they're right. This one is basically, because I know they are 90 degrees apart, correct? Yeah. So this one should be 90 plus 26.6. So if one of them is 20.6, 26.6, the other one is 90 degrees apart from that. We know that they have 90 degrees.
I mean, yeah, basically.
So now if I want to show them, I want to show that what's happening there, so my element would be look like this. And then that's going to be the X, Y. So that angle, so that's going to be my sigma max or sigma mean, I don't know. So that angle is 26 degrees. So this is 26.6, and the angle to the other one, which is, so I don't know, it's going to be 116.6. I don't know these ones, we are going to calculate these one and find out which one is sigma max, sigma mean, but one of them is sigma max, one of them is sigma mean. Don't know yet. So these are the angles. Then I want to know what's the magnitude for them. The magnitude for that was sigma average plus R, and the sigma average minus R. That was the magnitude for them. So you can go ahead and say find sigma mean and sigma max. So I want to find their magnitudes. So the equation for them sigma max, sigma mean is equal to the R is the sigma average, which was sigma x plus sigma y divided by 2 plus minus R, which was the sigma x minus sigma y divided by 2 squared plus tau xy squared. So sigma max, sigma mean would be equal to 50 plus negative 10 divided by 2 plus minus 50 minus negative 10 divided by 2 squared plus 40 squared. So it's going to give me two values. So sigma max would become max becomes 70, so sigma max is 70 megapascal, and sigma mean would be negative 30 megapascal. Okay, now which angle related to which stress? I have to use one of the angle and calculate the sigma for that angle to see if it's related to sigma max or sigma 1. So then we are gonna find which theta p is related to sigma max. So to do that, I have to put the sigma p in the equation, the sigma x equation. So sigma x prime you know that the sigma x prime was equation, the sigma parameter is the sigma x plus sigma y divided by 2 plus sigma x minus sigma y divided by 2 cosine 2 theta plus tangent the tau xy sine 2 theta. So that's the equation. So I'm gonna put the theta, so I'm gonna say theta is equal to theta P1 equal to 26.6. You can put any of them you want there, okay? So I'm gonna just put 26.6 to see what happens. If I put that there, then the sigma x prime would be (50 minus 10 or 16 divided by 2 plus 50 minus negative 10 divided by 2 cosine 2 times 26.6 plus 40 sine 2 times 26.6. So if I do that, the sigma x prime would becomes, what would be? It will become 70 megapascal. So then I can say that theta P1 is equal to 26.6 is corresponding to into sigma max, which is 70 megapascal. Okay, now I can go ahead and put them here. So the sigma max here, the sigma max is related to 26.6. It's going to be 70. And the sigma mean is going to be related to that 116, and it's going to be negative. So it's going to be sigma mean. How much was the sigma mean? Negative 30. So it's going to be sigma mean. Sigma mean is going to be sigma max. And the shear would be 0. Correct? And I have the sigma mean or sigma max. The tau is 0. At this point, the tau xy 0. So that's the first part, and the second part to find this, and that. The third part is asking how much the tau max. And where that's happening. So the magnitude of the tau max because I know that tau max happens when the sigma is sigma average, correct? Mm-hmm. So I know that when tau is tau So the tau max, or the other way around, so when the sigma is sigma average, the tau would be tau max. So the magnitude of the tau max, we have the equation for that, and it's going to be equal to radius. It's going to be sigma x minus sigma y divided by 2 plus tau xy, both of them square, root the square of them. So tau max would be, so it was 50 minus negative 10 divided by 2 squared plus 40 squared. So the tau max, it would be 50 megapascal. So that's the magnitude of the tau max. The sigma then would be the sigma average, and we know that the sigma average the equation for sigma average is just sigma x plus sigma x plus sigma y divided by 2, just sigma average would be 50 plus negative 10 divided by 2, which would be 20 megapascal. So that's the sigma average. If we want to find out, it doesn't ask us, but if we want to find out, because I want to draw it, find theta s. So if we want to find the theta s, sigma average. So if I want to find the theta s, again the tangent to theta s is minus sigma x minus sigma y divided by 2 tau xy. So tangent to theta s would be negative 50 minus negative 10 divided by 2 times 40, which theta s1 would be negative 18.4, and theta s2 would be negative 18.4 plus 90, whatever it is. So if I draw them, I want to draw that circle and see, okay, how it's going to look like. Then for the tau max, my element would be look like this time. So it's going to be my x and y. The sigma would be sigma average everywhere, correct? And it's positive 20. So it's got sigma average, which is 20. And it's going to be sigma average, which is 20. Sigma average. And another sigma average. So the sigma would be sigma average everywhere. And then the tau would be, tau max would be how much? 50. So tau max would be 50, like that. And if you wonder about the angle, so one of them is negative 18.4, so it's going to be this. Theta s1 is negative 18.4. Degrees, but rotating that way. And again, you know that the theta p minus theta 8, theta p minus theta s is 45 degrees. So you know, for the problem, you usually just need to know which equation to substitute the value into that. Any question?